Hello, welcome you all. Welcome to Ground Zero. Today we have got Vic. Vic is one of the most amazing personas on Twitter. On you might have seen him posting about the nails on AI research and all. So Vic spent 9 years at AWS, left to build Moondream, the vision models that keep embracing the big labs on practical tasks. 10 million downloads runs anywhere. Today we are talking about the why vision AI is harder than text, what's broken about how we train these models, and his bet that small beats big. Vikhyat, thanks for doing this. Thank you for joining this.
Yeah, thank you very much for having me.
Next, I would like to talk about Ground Zero, what Ground Zero is. So, past couple of months have been very fascinating for us. We have launched multiple things, community blogs, signals. We have been doing podcasts with amazing people in AI. We started with Token Vendor, then we did a very cool podcast with Will Brown, Kalomes, Janil Han, and yeah, the list goes on. Amazing people coming up, and we've been talking about AI, what's being going on Frontier. Let's start with the current podcast. Okay, who is Vic actually? Before I actually start the podcast formally, I would like to know what's one thing that keeping you genuinely excited these days. Not and like you're not saying on AI Twitter, but in a way you wake up and think about it, something like that.
Um, it's the most exciting part to me about like the world we're living in right now is actually if I back up for a second, when I started my career, it was around 2015. Um, I think it was kind of an era where like the technology didn't really matter that much. It was undifferentiated, and so what companies really cared about was like how we do sales, marketing, product positioning. And I used to read books about like the OS wars, the browser wars in the late 90s, early 2000s. And it was like a mythical world to me, like where tech actually matters. I think we're back in a world where like building really good technology engineering, like that matters again in a significant manner. Not to say that distribution and sales doesn't, but we're back in a world where like having cutting edge technology is something people care about and companies are really investing in. It's an exciting time to be in as a technologist.
Absolutely. I mean, we pretty much relate to all of this. Also, a logistical but revealing question. You are in Seattle, and most
Mhm.
AI stories pull up people toward SF. So, why Seattle, and why does that environment work for that kind of thinking you do?
Well, I don't think I explicitly chose to be in Seattle. I was at Amazon before this, and Amazon's here. Um, it used to be the case, I think, that location mattered a ton when you were trying to raise venture capital and whatnot. My co founder has been in the game for a while now. He tells me stories about when he was doing his first startup, like SFVCs would refuse to invest, and they'd have things like, what about board meetings? Like, do I have to catch a flight now? Um, I think being in SF is still very valuable. We visit very often, but being outside SF isn't that much of a big deal anymore. Like everyone talks on Twitter, everyone has the same access to Twitter, so it is what it is.
Totally makes sense. Next in the pipeline, before we will be really diving deep into what Moondream is, what goes behind it, and what was the idea around. But today, when you wake up, when you think what to do with Moondream, what it is being like.
Yeah. I guess the background on this is I originally started training Moondream because I was trying to build an automated UI testing application. Anyone who's written Selenium tests know that they're super brittle. They'll break if you change a class name or something. So GPT-4V had come out a couple months ago. I just gotten access. I started trying to do it, and honestly, it was pretty bad. It wasn't anywhere near close to the level of accuracy you needed to be able to deliver a product like that. And moreover, there were a bunch of issues where like if there was a person in the page at all, they would say, I'm sorry, I'm not allowed to process pictures with people in them, and all sorts of stuff. So I was like, okay, I've read a couple of papers, there's this lava paper, etc. Like, how about I go just train my own memory model, train my own vision model? It didn't have a name back then. I had a bunch of these lying around at home, which I got when I was doing stable diffusion fine tunes. So it was small mostly because that's what I could train on the hardware I had. And yeah, it was pretty positive about the results. Like if you show it a picture of a red ball and ask it what color it was, like 60% of the time it would get it right. So not very good, but there were some signs of life. And then I posted it on Twitter. thinking like, okay, I've done this, I'll post it, and now I can go on and rent some real hardware and train a real model. And a bunch of people got really excited about it for this reason, which was novel to me. In the case of vision, more so than text processing, the typical use case involves very high volumes of inference, whether it's processing real-time video feeds or re-annotating data sets or like digitizing documents. People typically have a lot of data they want to process, and the AI models at that time were like not that accurate when it came to vision anyway, and moreover they're a price point that was prohibitive. And so that was really how Moondream got started. It's still our vision. We think that the thing that is different about computer vision from pure text LLM still holds true. That's an unchanging fact in the world, which is people care a lot about inference cost. One thing that has changed in our approach to Moondream is that we are no longer saying that size comes with a compromise. Like for the capabilities we deliver, we're as good as the leading frontier vision models because nobody wants a discount VLM. And so that's been a large part of our focus for the last year is making sure that we are able to offer really fast, efficient models, but also without making compromises on visual reasoning. Now, there's other things that we are jettisoning to make sure that that's possible. So, like this model can't write code; it won't be able to solve AIME problems and whatnot. But when it comes to vision, we are and intend to remain state of the art.
Okay, in a nutshell, can you focus? Can you just say about when did you realize Moondream has really made it? I mean, a specific moment in the journey so far.
Well, I wasn't even paying attention to our Hugging Face downloads, and then one day
Mhm.
someone told me, "Hey, did you notice that like 2 million people are downloading this every month?" I was like, "Wait, what?"
Crazy. Like, let's get back to the story where it all started. So before Moondream, there was Hummingbird. I'm less interested in the official story and more in the lore behind it. What made you started and what originally pulled you in that idea when you decided to move on, and how did you know it was time as opposed to just another hard phase?
Yeah, this is a deep cut. Like it's been what like more than 10 years. Um, yeah, when I was in college, one of the summer vacations, I I'm always doing like some sort of side project or something all the time.
Mhm.
So one of my summer vacation side projects was I found a good data source of like anime that people have watched. Um, Scraped a bunch of that, built a recommendation system, posted it on the anime subreddit. It it got a lot of people excited because like there weren't any good recommendation systems for anime, and for Western audiences, like you don't really know what you should be watching or not. Um, and then yeah, that's when like my Hummingbird co-founder he'd reached out to me. He was trying to build more of like a community website of sorts um, in the anime space. It was called Hummingbird at first, and then later they rebranded to Kitsu. So yeah, I spent like 2 years working on that when I was in college. It was a pretty popular website. We got tons of users. I learned a ton building it. Like it's my first real system, putting it into production and getting a ton of usage, dealing with like Postgres corrupted data in the middle of the night and whatnot. It was a lot of fun, but ultimately like it was a little. I mean, back then, anime in Western audiences was pretty niche. It was like a lot of teenagers and stuff. I think the situation has changed now that like people have grown up. It's more popular, mainstream. There's more discretionary spend around anime. But back then, is not good. So we had a ton of
Do you still watch
usage,
anime?
but like the ad revenue was very low because advertisers didn't really care about anime audiences.
Do you still watch anime?
Not really. My knowledge cutoff is like 2015, 2016.
What was your favorite anime back in college days?
I It's hard to pick one. I mean, I was a big Full Metal Alchemist guy. I like That's a little normie as an answer. There's this more niche one that I'm a big fan of called was Darker Than Black. Yeah, big
Oh,
fan of that one.
nice. Can you share more about what happened later with Hummingbird, how it turned into Kitso, and what is going on right now at Kitso?
I mean, to be honest, I'm not super sure. So I left to join Amazon. I decided that making money was more important at that time in my life when I just graduated college. I know that my co-founder then raised a little bit of money, ran it for a while, but he's not involved with it anymore as far as I know. So the website's still up, so someone must be running it. I'm just like not sure who or.
Let's look back to AWS story because this is something, I guess, something very fundamental to Moondream and your career trajectory, whatever it has been like. Uh, so you spent nearly a decade at AWS, senior manager, solid trajectory, worked on AWS IQ from the outside. That's stability plus leverage, of course. So what broke internally? Was there a single moment, or was it a slow accumulation where you realized if I don't build this now, I probably never will? Yeah, maybe you can share the lore behind it.
Yeah, it was a bit of the latter, I think. So I had a great time at AWS for most of my time there. It's a great place to work, especially if you're like looking to learn how to do a lot of distributed system design, etc. I think around when GPT 3.5 Instruct or something came out, like before ChatGPT, I realized that there was like something going on over here, and that's when like I started spending a lot of my free time just like reading papers, learning about AI. When Stable Diffusion came out, that was like another big moment because that marked a change from when like as someone just like tinkering building projects as opposed to looking to get a PhD. That marked a shift from like, okay, I need like $100,000 to go and like experiment with this stuff, because back then there were no open LLMs or anything outside of GPT-2, to like, hey, this is like actually something where I can go fine tune it a bit, get real results, build a little business. And so that's when I really started leaning into AI on the side. I was doing AI adjacent stuff at AWS towards the end around AWS solutions and stuff, but it was a lot of it was like the best opportunities I could get at AWS internally for someone who wanted to work on AI was okay, like take it was like LangChain style stuff, like take a couple of take Claude and build a little agent to automate building a couple of like solutions. So wasn't super fulfilling. And I mean, this decade, like this is the most important technology that we're building, and so I had to be in the thick of it.
Pretty interesting. What do you think of Amazon AI right now? How much it is? I mean, how much it has been progress so far back when you left, and did this actually scale up? Because we actually see Amazon actually good at very infra level, like the technology you have actually you have worked on AWS. But what do you think of like how other frontier companies from the likes of Meta, Google, and all, how far or how at the level Amazon right now is?
Yeah, I think they were a little slow to get started, actually taking it seriously, putting the right people into positions. But I suspect they're fairly well positioned right now. I've not tried their latest models out, but they're posting pretty solid benchmarks. So I suspect they had a slow start, but they're probably in a pretty healthy place right now. Like to your point, they're very good at building infrastructure. They have no shortage of compute available internally. They got Trainium and Inferentia, and so again, they had like a bit of a slow start over there getting the compiler stack running, but strategically they're well positioned. I think they're starting to catch back up. I think a lot of people are sleeping on them. Like how many people have heard of Nova 2 or seen the benchmarks?
Totally makes sense. Let's get back to the holiday project because this is something I was hearing a lot about. Vic is working on holiday project and in your talks as well. So Moondream V1 dropped on late December 2023. So that was weird liminal week where nothing serious supposed to happen. Uh, so I'm curious what you thought you were building at that moment. Was this a holiday hack? Let's see if it works type experiment, or did you already have a clear thesis about small vision language models that you wanted to prove?
No, I didn't. It was definitely, I think I maybe started working on it like 3 or 4 weeks ago. I actually called that version of the model Moondream 0.
Oh, okay.
Yeah, no, it was just like me tinkering, playing around. I thought at best, like I'll go demo it at a couple of meetups, and then actually I did end up demoing it at a lot of meetups. AI Tinkers, like here in Seattle, New York, San Francisco. But yeah, no, there was no strong thesis back then. In fact, like being open source and posting it on Twitter, etc., is like what led us to learn a lot about the domain and what people care about.
Totally makes sense. You have a interesting college trajectory. You were based out of IIT Mandi. I remember it is a fairly very new IIT. How was your experience there? Like there are fewer templates, fewer expectations. How did that environment shape you out? Did the lack of legacy help you think more independently, or did it push to self calibrate harder? How was your academics basically? Yeah.
I mean, to be honest, dude, like I feel like college was kind of a waste of time. I like before I went to college, I was like really intimidated. I'm like it's an IIT, like there's going to be so many smart people here. Like, what's going to happen? I remember in the first like month that I was there was like a what do you call it? An internal competitive programming project
Hmm.
contest. And
Code Chef,
I
Code
went in
Forces,
like,
I guess.
what was that?
Code Chef, Code Forces, these sort of
Yeah,
things. Yeah, yeah.
yeah. I forget which one they use, but something like that. I went in like super nervous. I was like, "Oh, I'm gonna lose. Like, there's people who've been studying computer science for 3 years."
Did you do lead
Um,
code?
I used to do a lot of Sphere Online Judge when I was in during school, but I don't think lead code existed back then. Maybe
Oh,
I'm mistaken,
you are old then.
but um,
Okay.
but yeah, I go in like I'm kind of done in 20 minutes. I'm like, yeah, I'm done. Everyone is in shock, and that was when I realized, okay, like I'm like my self study during school and like doing side projects and stuff like put me pretty hard at it. I think I just spent like my 4 years there, like going to classes, learning nothing, and mostly learning from my side projects. So
I
kind
see.
of a waste of time. I guess I had fun there. Like it's a gorgeous campus. Made a lot of really good lifelong friends. They were very low attendance requirements, and so I was basically never going to class. So it was like it was all right. I'm not complaining about it too much, but it is what it is.
Interesting. I'm also curious about your co-founder dynamics because I guess you have overlapped 8 years at AWS.
Mhm.
So that's not a startup honeymoon, you guys. That's real exposure to meeting someone, having been someone for, almost a decade. So what did working together before Moondream teach you about how you would function under startup stress? And were there any assumptions about each other that turned out to be right or wrong, whatever?
Yeah, Jay was my boss at Amazon for like 8 years. We the way we got started was on the AWS IQ project. I'd done some stuff at Amazon before that, then I moved to this project. Jay came in a week later. He was hired as the director for that project. He'd done some time at Amazon earlier, maybe like 5 or 6 years before that, working on Amazon local. But yeah, we spent about 4 years working on that. It was a very, very difficult project to ship. Like there was enormous scope. We were a tiny team. Like when Amazon says that like, hey, we're really a group of startups, that really is the case. Like there's a lot of small teams. They don't give you, in a lot of cases, for successful projects, a lot of people up front to start building it. So it was a good experience. We really got along working with each other, and then post that, like as we were moving around the company, we always kind of found ways to keep working with each other.
I've always been curious, is Jay not socially active? Or,
Yeah,
I mean,
he's not very active on social media. He does run our Moondream AI account, and I have to
oh,
keep
okay.
nagging him to like post like, hey, you've not posted in 4 days. You gotta get something out.
Because, yeah, I mean, it's visible as all like you are the only face of Moondream. I'm also curious, how big is the team? Yeah.
Um, we don't want to talk about the exact team size quite yet. I don't know if like people from PitchBook and stuff are listening, but we're pretty
Mhm.
small. We're an order of magnitude smaller than like similar sized startups.
Mhm.
We make extensive use of like AI agents. I think we were maybe a little early to the game on like end to end AI agents without human intervention. I realized this maybe like late last year when I tried out Open Hands. And ever since then, every time we get to the point where like, okay, like for the next stage of growth, we need to hire like 2 to 3 more people, like some model drops, and I'm like, okay, I don't need to grow the team anymore.
Makes sense.
I mean, it's great. Like I've worked with Jay long enough. We understand each other. I think of all the reasons startups fail, like co-founder conflict is one that will not affect Moondream.
That's amazing. Sounds good to hear. Let's get back to the core thesis of this podcast. We'll get back to the technical details and how things work. So the core thesis, as I say, small and so this is where Moonbeam becomes philosophically interesting. There is a contrarian bet here. I mean, the entire industry is racing toward big models, bigger clusters, bigger budgets. So your bet goes in the opposite direction. What's the line of difference that keeps small models competitive or even ahead in certain regimes after your
Yeah, it's a
experience with Moonbeam? And what are big labs systematically overlooking because scale makes those blind spots invisible?
Yeah, I think the nature of our approach is very specifically tailored towards vision. There's a couple of things that are true about vision. The first we already talked about, which is like scale of inference. So cost matters a lot to people. When you think about how we process visual information, for example, right? Like we have our visual cortex, which is like very fast, rapid iteration, and then sometimes we think for longer. So there's like multiples, like some people call it system one, system two, etc. But there's like fast visual processing and then slow visual processing. Um, you We think of Moondream as like the visual cortex
Mhm.
of systems. Like if you look at a lot of what the big labs are focusing on right now, it's digital work. There's a lot of people that will argue that within the like next 5 years, a lot of like digital work, coding, building presentations, digital work is very likely to get automated by the current direction that a lot of labs are focusing on. We think beyond that, like think about how we're going to automate the real world, right? Like let's say you have this really came to my mind when I visited one of our partners, Driveline Baseball. And we went to their reception. There was nobody there. But it would make a ton of sense to have like a camera there that's like, okay, I was expecting these two people when they come in automatically unlock the door. If a UPS driver shows up and they're wearing the costume and everything, then also unlock the door and give them instructions to leave it in this specific area. Or when you have those cameras, like, hey, if someone's stealing something, notify the police. To be able to do that, you're not really going to call like a 100 billion parameter or a trillion parameter model. It has to be fast, so small. Item of interest has been detected, then that's when you do switch to the slower processing systems that like, okay, this event has happened. How do I react to it? And I guess the other aspect of it, which uh, is that like for whatever reason, and we can dig into this in a little bit, scale has just not worked out all that well to improve visual reasoning capabilities of models.
I see. I just got this thought. How did the name Moondream came up?
Again, like this was just a holiday hack, right? I didn't take it very seriously. I had ChatGPT generate like what are five good names for a small
That's
vision
interesting.
language model. The other leading contender was Opticon, and still our internal code base, like the Moondream training model, is actually still called Opticon. But I think at the last minute I switched to Moondream, which I'm very happy for. Like
Yeah, yeah.
Opticon was not it.
Totally. Next is you have said AGI research is a distraction, which is a strong claim and which makes sense. The strongest counter argument is that sufficiently capable general models eventually subsume specialized ones. What's the best version of that argument? And where specifically do you think it fails?
Yeah, I should clarify. I make strong statements on Twitter because people react and you get engagement. But I do believe in this for vision. Quite obviously, if you look at the progress that the big models have been making, like coding's probably going to be automated in 2 years and whatnot.
Of course.
So I guess my point here was like, again, it goes back to the same thing. There's like the fact that like cost is very important for a lot of systems. The argument that specialization is problematic is actually kind of true. When you look at the developer experience that people want, nobody wants to be training models, fine tuning them, etc. Or to the extent that they do, very little of it, because there's a lot of things that are very frustrating about collecting data and labeling them manually and whatnot. So you do want models that are promptable, very easily adaptable, but they also need to be really cheap, fast to run if you want to run the world and not just high value economic tasks.
Yeah. Also, in your own experiments, where do small model just lose? Like this is bit. This is a question of bit contradiction, but I guess you might have observed like where they really need a good push, like clearly and repeatedly. Let's say to compare to GPT-4V or Gemini. I'm especially curious about the areas where scale genuinely matters because that boundary seems crucial for anyone to push efficient models forward.
Yeah, I guess complex instruction following is one area. When you look at a lot of the prompts that people write for Gemini, it's like a few paragraphs sometimes. Like if you look at V0's prompt, again, significantly bigger than a few. It's a small book. Um, that's obviously something where like a fair amount of intelligence is needed to process those like conditional statements in the prompt. Another one I think would be long range agentic workflows. That's one where like as errors accumulate, like you end up in a very bad place if you're running a small model as opposed to a bigger, more intelligent one.
Yeah, totally. You have pushed Moondream from be down to half a billion parameters through
Mhm.
pruning. Is there a real floor here? Like, could we get to something like 100 million parameters and still retain usefulness, or do diminishing returns it hit hard at some point?
You're always making sacrifices when you're reducing model size. Our thesis when we started this company was really focused on deploying VLMs at the edge. And so we were doing a bunch of work around like reducing the size of the model, how small can we get it while still retaining as much capability as possible. And to be honest, like 0.5B was actually where we ended that experiment, realizing that this is not the way forward. Like you can get VLMs to run on edge devices, but you're making a lot of compromises. It's not that good. Like when you run it on your phone, for example, like it gets hot, you lose a lot of battery life, like, and you really care about that on devices that aren't connected to power. And inference is slow because you're pre-filling a lot of tokens. A lot of the demos you see on Twitter of like people running VLMs on the edge, they do clever things to hide the pre-fill time. Like they'll upload the image, it starts
Yeah.
to pre-fill in the background, then they'll slowly type the question in so that it's pre-filled and then they show it run really fast. So when you actually try to like deploy it in commercial environments, it doesn't make much sense. And so what you're sacrificing is a lot of accuracy and the promptability. If you want to keep the accuracy, you have to drop a bit of the promptability and like specialize on certain domains. At which point you start to think like, why even deploy a VLM at the edge, right? Like there's architectures that people have optimized for a long amount of time. There's the YOLOs, Tethers, etc. And I think for a certain class of edge, like if it's inside a camera, for example, or running on a flow, you don't really want a VLM. You are deploying this on like millions, sometimes billions of devices. So you have the budget to go like actually train a strong, small, specialized model for the case use cases you care about. There's also slightly bigger edge devices when you think about like Jetsons and Orins, or like if it's an office, like them putting a little GPU gaming desktop to process their video feeds. That's where more of our focus is shifted, where you actually have enough computational capacity to do interesting things while still being real time, while still retaining like promptability.
Makes sense. I'm curious about what are the top three amazing use cases you have seen people using Moondream for. I mean, which you had not expected, but something like they are fitting Moondream at some point at certain problem statement that do wonders, or that's very amazing to see.
Yeah, I guess like some of these are maybe not surprising.
Mhm.
Computer use has been like a very common thing people are
Yeah,
using Moondream for, which is slightly surprising in the sense that we've not actually done a lot of the things that we're about to do to make it a phenomenal model for computer use. But the fact that we have those point object detect capabilities are highly accurate are pretty useful for people. And a lot of people deploy it in setups where they need a fast switch. Like Moondream will attempt to perform an action, and if it's wrong, then they will call a bigger model that's slow and more expensive. A lot of broadcasting type use cases where like people have video streams that they're broadcasting live, and then they're just using Moondream to enhance those video feeds.
I guess Mountain can usually, I mean, perception is one of the thing which is really, I mean, it's traveling a trajectory in the vision robotics problem. And I guess, like, what do you think of Moondream settling up at a place in the perception layer of AI? Like, not now or now, but let's say 5 years down the line.
Not 5 years, it's say 6 months, but yes, that's kind of
Okay,
exactly where we're positioning Dream, right? Like it's the real-time visual cortex for your application.
I see. Okay. Okay, a lot of this seems to be back to data, not architecture. So we'll be talking about bit of the data problem. So, in your experiments, what are some of the obvious vision takes that turned out to be secretly broken because of the data bias or data absence, or what do you think of it in very general sense?
Yeah, I think this is one of the reasons why just like blind scaling has not led to state of the art vision understanding in the frontier models. It's We train these models on a lot of data sourced from the internet. And the problem is humans are just so good at seeing that we don't really write down a lot of the things that we take for granted. Like, okay, I'm seeing these two buildings. I think this building is further away because it's a little smaller and the perspective is a little weird. And or I think this road is downhill, not uphill, because I'm looking at the angle of these. Like we just don't write those things down. Sometimes we don't even know how we know. We just know that this is the scene we're looking at. So data is a huge problem, and I think that's one of the big blockers for getting high quality vision AI, and that's why scale hasn't worked. Solutions to this are you either do like pure self supervised learning, like just on images, which is promising line of work. If you take Dino V3, for example, and then another work where they scaled up to self-supervised to 8 billion parameters, they're getting pretty like, can you build strong vision understanding just by looking at images without any paired data? Um, the problem with SSL techniques is like they're very, very, very compute intensive. You need to pour a lot more compute into that than you would if you had a large scale source of labels. The others, we do a bit of that. Like I posted a bit about some Jepper stuff that we've been doing. We treat it as like an auxiliary loss to boost how much we're learning from any given sample. But if we were doing just that by itself, we'd be pretty screwed. What we invest in a ton is synthetic data. And this takes many shapes. It's real world images with noisy annotations that we're filtering, enhancing, augmenting, correcting. It's sometimes synthetic images that we generate. And this is actually a really hard problem. Well, it's not a complex problem, it's
Mhm.
a complicated problem. It's pretty straightforward to do, but you have to pay, like, you need to have a lot of attention to detail. Make sure you're minimizing error rates.
Yeah.
Then there's also this like precision recall issue where the more accurate you make the data, the more of it you're filtering out. And the more you're filtering, the more likely it is that you introduce some other type of bias that you
Yeah.
weren't anticipating.
That is not real. Yeah. Makes sense. Um, so you have said something that stuck with me. The actual data on how to look at images isn't really present on the internet, and that totally makes sense. Humans don't write tutorials or on perception because we are too good at it. So is this permanent ceiling for VLMs, or can synthetic data meaningfully close that gap?
Our bet is that synthetic data will close that gap, but you're absolutely right. Like when it comes to thinking, we have books about how to think about math problems. We have books about how to think about thinking about math problems. There's like so much content about that, but there's nothing about images. Or there's very little, maybe like some books about art where you're saying like, okay, when you're trying to paint a mountain range, here's how you build perspective. But outside of that, yeah, it just doesn't exist. I don't think this is a permanent ceiling. There's like enough economic value here to where people will collect the data that we need. You can either generate it cheaply synthetically, or to the extent that doesn't work out, like you can deploy a bunch of cameras with additional sensors and detect more things.
Would also like to know about the story behind RefCoco Am, because why and how RefCoco Am, how bad was RefCoco actually? What was the philosophy on building this?
Yeah, we were adding segmentation as a new skill to Moondream because a lot of customers have been asking for it.
Mhm.
The specific type of segmentation we were adding, there's many types. We were focused mainly on referral segmentation, which is where you type something. In our case, we also allow you to type something and maybe add a point saying this specific one and have it return a segmentation mask for that specific item. Now, when it comes to referral segmentation, there's two things you care about. There's the referral aspect, like is it roughly picking the right object? And then the actual segmentation quality, which is like, is a mask tight? Is it hugging the object? RevCoco was decent at the former. There were some issues with the labels, but not devastating. But what was devastating was the mask quality. So once our model got like reasonably good, we weren't able to actually measure progress with which is benchmarking it. So we created a synthetic pipeline to enhance the quality of masks. We released the benchmark splits of that as RevCoco, just so that, yeah, once you reach a certain score, like it's basically noise, and that score is somewhere between like 70 and 80, depending upon which RevCoco split.
Got it. Okay, let's get back to architecture. I was looking up to Moondream Cloud, Moondream 3, and you have escalated from dense to AMOE decision. So why AMOE over dense, and how much good or bad it is for vision? What one should be aware of while choosing the architecture and configurations?
Yeah, my favorite thing to talk about.
Mhm.
Um, when you're looking at deploying models on edge devices, a mixture of expert model makes zero sense
Yeah,
because you're memory constrained, and in a mixture of experts, like you have to load all of that memory. So even if you're reducing um, the number of active parameters, sorry, even if you're, yeah, if you're reducing the number of active parameters, you're not really gaining a lot in terms of the devices that you're able to deploy to. When we decided to makes this switch from like edge to like more, I don't know what to call it, like systems with higher computational capacity. We still want it to be really really fast, but we did want to deliver frontier vision performance. And to some extent, if you're just like 2 billion parameters, you're making some compromises on how accurate you can get. And so yeah, we spent most of the summer trying to figure out like how to get stable MOE training going. B was actually a mistake. I wanted it to be 12B, but I made a mistake in the math while
Yeah.
calculating it and realized halfway through training. So but it worked out okay. Like I don't think that made a big material difference in the final quality we were able to achieve. But yeah, the reason we switched to a mixture of experts is we want to get to like we want to no discount like actual frontier vision reasoning model, and to do that while still maintaining really fast inference. The best technology available to us right now is a mixture of experts architecture.
What do you think the next iteration of the models, let's say Moondream MD5, MD6, MD7, you will be scaling on the same architecture or some other alternative like transformers or something?
We're not making major architectural bets because we're not really a research lab. We think of ourselves as more as an engineering lab that is trying to solve vision. A lot of the research bets that you would make to explore different architectures involve like I don't know 3 to 4 years of R&D, and we do a little bit of that on the side, but our primary focus is like taking the existing architecture. We'll deviate in certain ways where it makes sense because we'll introduce optimizations that make sense for our size and class of model. But besides that, like I don't not really interested in doing extremely novel things.
You just talked about expert specialization. So let's say the expert specialization with 64 experts. And do certain experts own specific visual tasks? Like, is there an OCR expert, a spatial reasoning expert, or a specialization more diffuse and emergent?
It's more diffuse and emergent. We did 64 experts with top 8 selected for each token.
Mhm.
So it's more fine grained than Mixtral, for example, which I think was 4 top 2 or something like that. I forget the exact details, or 8 top 1, 8 top 2, something like that. So this was something we actually derived from the All Moe paper, where they did a bunch of experimentation on this. The thing about 64 choose 8 is like it's a lot of different combinations that are potentially possible. And so there's a ton more diversity in the choices that the model can make. So that makes it really hard to interpret like why the model is choosing any particular set of experts for a given token. It's not really tied to modality, it's not really tied to type of task, it's just whatever the model decides.
What are some kind of you think more can be improved on routing mechanism or on the MOE side of the things?
Yep, routing is a fundamental problem in mixture of experts. It makes optimization extremely difficult
Mhm.
because when you take early stage MOE training dynamics, for example, right? Let's say when you start completely from scratch, randomly initialized model, um, every expert is getting approximately the same number of tokens, but due to random chance, one expert might get 1% more tokens. Now that expert is better than all the other experts because it's seen more data. Then the router starts like pushing more tokens there because it's better, and then you end up with collapse. And so we apply a bunch of like load balancing losses to stop that from happening. But the load balancing losses sometimes prevent specialization because they're forcing too much convergence, and sometimes they interfere with the gradients from the actual tasks. That's a big problem. And then the other problem you have is like sometimes routing shifts, like when you switch from like pre-training to mid-training slash SFT to post-training, your data distribution shifts. And so either like you lose your load balance or you apply it again, and there's a lot of catastrophic forgetting because routing changes. That's a fundamental problem with training MOEs. A lot of the big labs and some small labs like ourselves have figured out how to make it work, but very few people actually publish all of the tricks into getting efficient MOE training. So it's
Can you throw some light on what actually it boils down to? Like when a small lab is working around it, is it more on the configuration side or it's about really on the low level side of the things?
no, you need to monitor a lot of metrics that cause collapse or inefficient training over the course of training and apply interventions. Like it's a far more active process than you just like start the training job and let it run for 6 weeks.
I see. Next, I was reading your blog or the tweet, something on those lines. You talked about this grounding token observation. So you had mentioned Moondream uses two tokens for points, three for bounding boxes, and competitors use tens of tokens. So how did you arrive at this representation? I was just curious, why did you try out that didn't work? Yeah.
Um, yeah, I forget the exact history on why we tried it. I don't think it was like quite efficiency oriented because you can achieve the same. So the actually back up for a second. Moondream does not use text tokens for grounding tasks. It has a separate set of, I forget exactly. I think 1,000 plus something like 3,000 ish tokens in a separate like dedicated tokenizer that is
Hmm.
used to predict points and images and bounding boxes.
Hmm.
One of the big reasons for that is when we were a really small model, we didn't want interference between like the model to get confused between what 723 means in the context of math or OCR versus in the context of pointing at stuff and images. And it's fairly cheap to do. We write all of our training and inference code from scratch. It's completely custom, so it's not hard for us to add it. Whereas if you're building it into an existing system, existing trainer, it's pretty hard to do. So that worked slightly better and we stuck with it. But it had major benefits for inference efficiency. If you look at how Quen does object detection, for example, they generate a bunch of JSON with like numbers and it takes up a lot of tokens. And so this choice ended up being very helpful for us in reducing inference cost and inference speed. Because like if you
Let's get back to the Super B tokenizer. The custom tokenizer in Moondream generates 21% fewer output tokens. So that's significantly for cost. What trade offs did you accept to get there? I'm also curious how good big labs are open to try out these new techniques for their experiments.
there wasn't any real trade-off. Like there was no like super BP is just such an obviously good idea. The core change it makes tokenizer training is typically people split on white space, and that leads on there's only so many like tokens that you can generate with English. And so once you go beyond that, you start to create tokens for like really really rare words. And so super BP says like okay, like after a certain point we will remove the restriction on white space splits and allow tokens that contain spaces like
Mhm.
and so that allows you to compress very commonly used English phrases like and made or made the from the street into a single token. So it just gives you a better tokenizer. I think it's just like there's many variants of Super BP like tokenizers. There were a few papers that came out around the same time. There's also a lot of like more sophisticated tokenizer training techniques that um, historically it's been like an underinvested area of investment. But yeah, there's no real trade-off. I think it's expensive to change tokenizers when you already have like a lot of pre-training invested into a model. That's probably the big constraint on why people have not adopted stuff like this. But besides that, yeah, it's no brainer. Not only does it make your inference faster, by the way, it also makes training more efficient by basically the same amount of speed up because model performance is ultimately connected to how much text they see, not how many tokens of text they see. So if you have a more efficient tokenizer and this with the same training budget, you can get 20% more tokens than if you were using our tokenizer,
I
for
see.
example.
Interesting. Um, this is something I was particularly curious about. I guess the last time we actually met in SF and you were talking with someone, like, I guess you were running an RL experiment and you were very bullish on that experiment. I'm not sure what experiment it was, but you said like RL dominates pre-training. Like you mentioned that reinforcement learning post-training now uses more compute than pre-training. And that's why what reward functions work for visual reasoning? What failure modes did you discover in this pipeline?
Yeah, it's it's a hard question to answer in a generic way because every single vision task has kind of like a unique reward function that makes the most sense. And we spend a lot of time iterating on this. We currently spend more compute on post training, like the RL fine tuning phase of the model, than pre training. Um, and there's just a function of like how much we've seen relative improvements. Like if we spend 50% more time on pre training, for example, we'd get this much improvement in the benchmarks versus if we invest the same compute in more RL after the pre train. The math was basically based on that. Um, I think it's especially useful for vision tasks because one of the things RL shines at is handling problems where there's multiple valid solutions.
Hmm.
And for take object detection as an example, when you're doing pre-training, you either define some like set order, like okay, I'll go top to bottom, left to right for the objects that are in the ground truth of the image, or you just randomize it, and that gives very noisy gradient to the model. It might be trying to predict the second box, but you're saying the first box is correct at this position, and so it gets really noisy. With RL, you can say, hey, as long as the collective set of boxes that were predicted are correct, give it a good score. So for a lot of grounded visual reasoning type tasks, RL is just like a lot better than pre-training when you're trying to do it auto-recursively. There's other ways to model it, but for us, this is what's worked really well.
I see. I'm also, I was just thinking around, does training on OCR hurt object detection? And how do you handle conflicting gradients here? Yeah,
So far, we've not seen adding a task cause worse performance in other tasks, which actually points towards the bottleneck not being model capacity, but actually ground truth data or the training techniques that we use.
I see.
So yeah, in short, you need to balance them a little bit so that you're not overtraining on one and causing catastrophic forgetting in other areas. But as long as there's some rough semblance of balance, you're basically fine.
It makes sense. Also, can you share more about training recipes for Moondream 3? I mean, to a general audience, what's unique about that?
I guess at the highest level, the entire journey went like this. We started from Moondream 2B. We found a way to upcycle it to a mixture of experts, so we're not training it from scratch. We spent a bunch of time figuring out how to get stable expert assignment without wasting a lot of compute. And then we invested really, really, really heavily in reinforcement learning. That's why Moondream is a competitive model. It took us like a year to figure out how to make reinforcement learning for vision work really well. And yeah, the initial release was at like 55 different vision tasks. We're closer to 200 different tasks that we're doing during RL right now.
You might have seen that people have cross opinions on RL training and using RL a lot of times. People optimize for more. I mean, they just say sometimes RL doesn't work. So, what's your take on that? Like, I see you are bullish on RL training. People use Chapa and all that stuff. So, what's your general perception on this lines?
Yeah, I think a lot of people making those kind of arguments are making philosophical arguments that like RL only improves
Yeah,
the base models understanding, or like I think self-supervised is the future because blah, blah, blah. I don't really care about physical like philosophical arguments like that. Like I look at what works for us, and that's what I scale up.
got it. That makes sense. This is something people were curious about your business model. So Moondream is amazing because it's small and open source. Edge reference is quite possible. I'm curious about your business model and how AMD makes money. Yeah.
Yeah, we're still pre-revenue. We've launched our cloud business, but we've not spent a lot of time like really pushing for growth over there. Our ultimate, like our top line metric that we care about right now is overall Moondream adoption.
Mhm.
It's a pretty like there's open source business models are pretty well understood right now. Like your top priority is to build a large user base, and then you monetize at the edges for things that enterprise customers care about that open source people might not care about all that much. So it's pretty straightforward. It's low risk in a lot of respects. The one thing that's different is like one benefit traditional open source businesses have is like contributions from other customers. In Moondream's case, our primary expense is model training, so that's not really something we can get help with. But besides that, like we're not doing anything really novel on the business
Mhm.
model side. It's how any other open source project is going to monetize.
I see. Also, what's wrong with the current VLM development priorities across the industry? Also, I'm curious about the focus of current AI frontier on the vision task. Everyone is trying to scale down on either the architecture or either the recipe on the text side of the stuff. I mean, there are very few labs which are actually working on the vision stuff. I mean, let's say OpenAI as well. They are also optimizing the newer model which are coming up. Let's say 5.1, recently 5.2, from the scale of 4. What do you think about the frontier of vision AI as per the current standard?
What's wrong with the way people are building VLMs? The benchmarks are all wrong. The benchmarks that people are using make zero sense to me. Like there's one called Math Vista, which is basically you take a picture of a math problem and then you ask the model to solve it. That's a math problem, not a not a VLM
Yeah.
problem. So the benchmarks that people use are pretty bad and they're very disconnected from what customers really care about. Like we talk to a lot of customers, um, very disconnected, and so a lot of people who are actually trying to deploy VLMs don't find them useful in production because they're just optimized for the wrong types of tasks.
Mhm.
Types of vision that the frontier models are interested in are mainly assistant slash agent focused, right? Like Anthropic, for example, cares about vision to the extent that it helps Claude code, that you're able to see a screen that it's building or paste in a screenshot of a stack trace, and it helps. That's their primary focus, or it should be their primary focus, and it appears to be the case as far as their capabilities go. There's not a lot of people focused on, there's more than there were when we started this company, but there's still not a lot of people focused on getting that like real time visual cortex, real world understanding type of vision AI that's going to power the real world. And I think a big reason for that was that VLMs were just not ready until very recently. I think we're just on the verge of them being accurate and fast enough to actually deploy in large production use cases. That's going to happen next year.
I see. I also think vision is one of the problem. I mean, it is varied problem. It comes with different modalities. It comes with
Mhm.
different forms. So, according to you, with this experience so far, what you see as one of the hardest problems in vision AI?
There's no individual problem in vision AI that's really hard. The problem is there's so many of them. If you look at the output modalities people care about for vision, like sometimes you want to do object detection, sometimes you want to get depth maps, sometimes you want to do segmentation. In each type of potential output that people care about to build their applications, there's many different variants. Like segmentation, there's 5 different types of segmentation that
Yeah.
people want. Sometimes you want pose estimation. You want all of these capabilities. You want them to be highly accurate and run in near real time. It's less any individual problem, more like the whole breadth of problems that you have to tackle.
First, I want to, before going on the coin question, what's your general view of open source AI from US and how you see comparing with the Chinese frontier? And I'm also very much curious about the Quen question, how they are doing so many incredible things. Actually, in vision, like the Quen VL model, what do you think of it on those lines?
Um, yeah, I think in the US there's historically been underinvestment. I say historically, I say in the last, I think it's only like since DeepSeek that US investors have been more open to investing in, forget open source, in any companies that are training
Yeah.
models. It's been the case that, yeah, like we've all seen the video of Sam Altman going around and telling people it's game over, don't even
Yeah.
try. A lot of people took that seriously. And even when we were raising our round, like one potential investor was like, can you guys promise that you will not become a model training company? So there was a lot of reluctance to invest. I think a lot of it was because like the leading labs in the US were like, yep, it's over. Nobody can compete with us. And then DeepSeek was the big, like people call it the DeepSeek moment, right? Like DeepSeek was really who flipped that narrative and made people a lot more open to investing in it. Not just VCs, but also people to come up and say, actually, like, I guess it is possible to compete. Um, so there's a lot of people working on it now. I think the situation will be a lot better 6 months to a year from now
Mhm. I see.
in terms of like US developed open source or just like alternative models in general.
What's Vic favorite or the best, according to you, open source company out of America after Moondream, of course?
I'll have to go with Alan AI.
LNA. I see. Um, any thought?
They're also based out of Seattle. We've hung out a couple times. So
I see. The team is crazy. What's your view on DeepSeek OCR? Yeah, I mean, it
yeah, I
sometimes
mean,
come up with very interesting stuff out of nowhere on the OCR things, and it just go crazy. So, what's your general perception on those lines?
I think DeepSeek OCR is actually an example of people on Twitter not knowing what they're talking about. Everyone got excited about it because of the DeepSeek name. Um, but like it was an old model that they released I assume they were probably using it to like generate training data for DeepSeek V3.
Mhm.
So it was not competitive with like state of the art. Like it was state of the art OCR models at the time. Like Dots was better, Almost CR was better. So it was not a state of the art OCR model. To add to that, there was like some weird shit about optical compression and whatnot that made no sense in that paper. And yeah, I mentally downgraded everyone who was posting like hype tweets about it
Mhm.
in terms of uh, how much I should respect their opinions.
Makes sense. Yeah, so this was interesting to me, the Moondream acquisition. So someone on HN asked why you haven't been acquired by a big lab yet. I've also heard that Apple tried to acquire Moondream. Is that on the table, or what would make you say yes? Yeah,
Uh, I don't think I should comment on like specific acquisition opportunities. We've had a couple of people reach out with interest in acquiring. It didn't go very far because we're still early in our journey. Like we see a lot of promise in what we're building, and we still have like money in the bank. So like there's no urgent need for me to go and get acquired. That said, like if the right opportunity comes along in terms of dollar amount and more importantly like alignment, mission alignment, we'd certainly consider it. But for now, like being independent makes the most sense for us.
totally. Um, I'm curious about what the next for Moondream. Let's say 2027 Moondream.
Yeah, it's really that like there's a lot of visual data in the world that is currently basically being written to dev null. Like there's an enormous number of security cameras. There's all of this like visual information that we produce that is not being fed into intelligent systems to act upon. Moondream's role in the AIification of our life is to really be at that layer, which is the fast twitch first layer visual intelligence system.
Are you actually looking up to image generation or pre-training arenas?
Well, image generation is not really in scope for us. We drive our roadmap primarily based on what customers ask us for, and image generation is kind of a distraction. It's a very
Yeah,
valuable field, but it's also like it's kind of a distraction from perception, which we've not
yeah.
solved yet. So it feels like why go tackle that? In terms of pre-training, like we already do pre-training, so I wasn't sure what you meant by that.
Pre-training, I mean, like starting from scratch, not using any base model kind of approach.
Yeah, I can't say we've strictly started from scratch because we do use Siglip as
Yeah,
our vision encoder. But besides that, like the text model, etc., that's all trained from scratch by us. So I'd say we're a lot further along on the like building our own model than a lot of other companies that are just shipping Quen fine tunes with a different name.
I remember your AI engineer talk, and you have been talking about, yeah, pre-training is not in the scope as of now, like from the scratch.
Yeah, that's changed. That's changed since then. Like Moondream 3
I
uh,
see.
was pre-trained. Part of it was we're making architectural changes to the model
Mhm.
in the pursuit of efficiency that necessitated. We don't do anything just for the sake of it or to be able to say we do it. We do it if it advances our goal of building really, really efficient,
I see.
accurate VLMs.
What's underrated and overrated approach in AI research right now?
Interesting question.
Let's go with underrated one first.
I guess one aspect of this is just like a lot of people are spending time publishing papers that don't really move the needle.
Mhm.
There's a lot of people focused on volume as opposed to quality, and that's hurt the ecosystem in general because like these days I don't even spend time reading papers. I used to like go to archive every morning, like find interesting papers, read them. But now, like in a lot of cases, like the rate of like reproducibility has dropped immensely, and then just the quality of like the scope of the work, right? It's like okay, I did this and I got this result. It's like, dude, that could have been a tweet. Like you didn't need to write a 6 page paper about it. I would love to see people switch to like a more slower pace of research when it comes to publishing and focus on like more impactful work as opposed to just getting as many papers out as possible.
Okay. How was Neurapius for you guys?
How's what?
Neurips for you guys?
Oh, I didn't go.
That's interesting.
I was busy grinding, man.
That's amazing. Makes sense. Okay, best paper you read this year.
Um, it's actually a very niche one. I don't even think the paper was like super well written. It's called Selective Self Attention. I'd say best paper. The way I found it was like I was trying to do long context extension for Moondream to get us to 30K context length. I had this one idea of like maybe the temperature should be a function of the position ID. So I asked ChatGPT like, hey, do you know if any papers are doing things like this? And it brought that paper up. They had two extensions to my idea, a bunch of like ablations. There was like some minor writing quality issues with the paper that I think caused it to not get that much traction, but that made like a big difference in our model training. And I think we actually briefly covered that in a. You might have had it in one of the screenshots above where we were doing
Yeah.
selective attention and Moondream 3. So
Yeah.
in that sense, I'd call it the best paper because it had the biggest impact on our model and also underrated because I think very
That
few
makes
people have
sense.
seen
I
it.
mean, you are reading a literature and you're actually using in your production pipeline, which is making go to the frontier. I mean, what could be more
Mhm.
amazing than that, of course. How has Twitter helped you out, or how the journey has been? Like maybe your on the personal identification or for the moon dream at all. Yeah.
I mean, it's been hugely valuable. I actually started focusing on Twitter maybe 2 years before Moondream. I was trying to do some random like side projects and I was getting like no distribution. So at some point I realized distribution is really
Yeah.
important. So I started tweeting a lot and basically trying to build an audience.
Do you
It's
have a
hugely
number
valuable.
or a general perception about the proportion or the ratio of the distribution of moon dream from Twitter?
I think almost all of it ultimately comes down to Twitter. Like the that's how the project got started. I'd say maybe 70 to 80%.
I see. Interesting. Uh, what are your thoughts on world models?
They're very interesting. Well, I see them as a class of synthetic data.
Mhm.
It's a class of synthetic data that is very expensive to generate because you have to train this really expensive model.
Yeah.
And it is also prone to like the bias problem. The world model only models what the world model can
Yeah.
model. And so that's all your actual model can learn. So which is not to say they're not useful. Take Waymo, for example, right? They need to compress really intelligent models to run on like smaller real-time hardware, and they have practically infinite budget. And so I think it makes a lot of sense in those settings.
I see. I'm curious about what AI environments do you look up to? Like there's American AI, there is Chinese AI, there is European AI developing now, and I'm also curious about what your thoughts on Indian AI and how do you differentiate them? Like let's say in,
Sure.
in a line, like every such environments. Yeah.
Yeah. I guess what I will say is that like the trajectory I've seen at first with American AI is like very closed, very safety focused, EA adjacent, etc. Everyone knows they were trying to like ban data centers, bomb them. There was that rhetoric. And so I think like the rise of Chinese AI labs really helped stop that sort of narrative and make everyone like more grounded about the reality of what this technology can do, the risks it actually poses as opposed to some like science fiction runaway super intelligence that turns us all into paper clips. So that was a big shift in thinking. I do think like the fact that we have like the internet and everyone talks to each other reduces the amount of differentiation you see over time across these different like landscapes. People see what works and like there's a lot of diffusion that happens, which I think is very useful.
Do you have thoughts for other ecosystems as well? Let's say if I have to ask about Indian AI.
I mean, I don't know much to be honest.
Mhm. I see.
I don't know what the scene in India is like. I've not really participated in it too much.
Makes sense. I guess we can move ahead to community questions. We have got many to cover. So this is from Josh. Do you think tiny VLMs will be able to completely automate digitizations of documents at scale, like 10K plus documents a day? What are still the unsolved issues regarding correctness of the outputs? That is parsing tables, diagrams, figures that hinders end-to-end digitization.
Short answer, like yes, but you would expect me to answer yes, given what I work on. I guess the big blockers is in diversity of documents. If you're saying like I have 10K documents of the same type today, they're all like insurance forms, or like I have five different types of forms that my company processes. It's already ready today. You might have to do a little bit of fine tuning for your specific document types, but you will that is already a solved problem. The problem that is not solved right now is how to deal with like complex, highly detailed tables. If you're just taking like arbitrary engineering textbooks, for example, and expecting to digitize them, that technology is not quite ready yet with VLMs, because dude, there's like so many like random ways in which people do tables and charts and
Yeah,
stuff. Um, they're the real gap. Yeah, it's with tables and less so with diagrams. It's tables and charts that are really hard to nail in a general way. Now, if you have a specific type of table format you care about, it's very easy to get the accuracy that you need.
makes sense. Next is, how do you decide what vision problems are important enough to focus on? How much and what kind of synthetic data do you generate? I guess the answer of first question is being answered, so you can talk about what kind of synthetic data. Generate.
Yeah, how much? Like shit tons. I don't know, lots. We probably spend more compute on generating synthetic data. We definitely spend more compute on generating synthetic data than actual like training of the model. In terms of what kinds, again, there's like so many different kinds. So I can give a couple of examples. When it comes to image captioning, one problem is like most people train on just like pre-train on alt text associated with images from the internet, and that tends to be very noisy. So what we ended up doing was we just used Moondream with a prompt that's like, hey, given this image and this alt text, can you come up with a caption for the image? So there you're because you're conditioning on the original alt text, the model still preserves a lot of the diversity entropy in the source material while still correcting errors, removing obvious mistakes, and so on. So we did that once. We reannotated our entire data set and then we trained a new version of Moonream. Then we repeated it and the performance went up even more.
That's interesting.
And I'm not just talking about captioning performance, it's like other visual question answering type questions and whatnot. But that's an example of the type of synthetic data we generate. It still has to be grounded in some real world signal, because otherwise you end up with massive amounts of bias and it just doesn't work well.
What's the secret? Not, but actually, is it in data? Of course, in training models and distilling them. Obviously, it's a combination, but multi-stage training, RL, even. What's the best advice you have to tackling these larger problems?
Um, yeah, it's like Matthew said. There's not one big secret. It's a it's a thousand different things. We innovate across the stack. Like with our tokenizer, that reduces our training cost by 20% to get the same output. We invest a lot in RL. We generate a lot of synthetic data. I think the biggest, if I had to like step back, I think our biggest strength is we're vertically integrated. We do everything end to end, from like collecting the training data, building synthetic data, pre-training, mid-training, post-training, inference, RL. Owning that entire stack allows us to like take advantage of opportunities that require changes in multiple stages. Like your model architecture affects both pre-training efficiency and inference efficiency, so you need to strike a balance. Sometimes there's an optimization that you need to do that hurts this benchmark a little bit, so you need to generate more data to overcome that, etc. So um, really it's the fact that we're tackling the entire life cycle of training this model and running it in production, and the fact that we're innovating across the stack, not just in like specific areas.
Makes sense. Would like to hear your take on stitching together small model calls and what he's saying emerge.
Yeah, in general, I think end-to-end training will subsume the need for stitching together multiple model calls. Historically, we've seen this in computer vision for a long time. If you look at old school pipelines for, I don't know, things like pose estimation or gaze detection, it's people chaining together like 16 different tiny models doing very specific tasks. Like this will detect the head, this will detect which direction they're facing, that sort of thing.
Mhm.
Anytime you introduce a seam like that between like two components of your system that are ultimately trying to produce an output, you introduce errors that cannot be corrected by downstream systems. If you have an end-to-end model, like I guess I'm saying you need to have gradients flowing in through end-to-end. It's It's kind of that Tesla software 1.0, software 2.0 thing. I think ultimately end-to-end training will subsume all of those.
Totally makes sense. We see papers such as less is more, hiring reasoning models. Recently, what would be high potential architecture for the small models?
Yeah, again, we don't. What was that?
Given the MOE, like you have been training on MOE, so yeah, given the like what potential architecture do you see?
Yeah, I put techniques like tiny recurrence models, etc. They're in the novel category. There's anywhere from 2 to 5 years of research before they're like generally deployable. And so we don't focus a lot on that. Our focus is more on like smaller tweaks to existing architectures, things like grounding tokens or better ways to do reasoning, etc. Faster sparse attention. Our preference is to stay within the existing framework of like what works and optimize within that as opposed to explore brand new things.
Makes sense. Do you have any plans to bring back your examples for fine tuning? Also, do you have any performance stats about the model once it's been tuned?
This is very timely because early next week we are about to launch an RL tuning system. The documentation for that is already up on the website, and I assume by the time this podcast is out, it'll
Mhm.
already be out. Um, RL is, in our experience, the best way for customers to tune Moondream because they're typically trying to tune it on a task where it's already kind of able to do it, and they just want to push accuracy. In terms of performance stats, I have an interesting example to share. This is we train Moondream to play GeoGuessr, the country guessing version of GeoGuessr. At first, it was at around 5% accuracy. No, it was 10% accuracy. 5% is about like random choice.
Mhm.
The best model we tested was actually Claude 3.7 back when we did this experiment. It was at 67%. We trained Moondream on 20 images per country using reinforcement learning, and that got us to state of the art. It was like 70 plus percent. Then we were like, how little data do we need to actually get to SOTA performance? And the answer turns out to be between 1 to 2 images per country. So if you do one image, you're like a few points below Claude's SOTA performance at the time. And if you do 2 images per country, you were above. And so that's interesting, right?
That's
Like
pretty interesting.
the real problem with fine tuning is data collection. And if all you need is 100 images or like 50 to 100 images, you can collect that in an afternoon. Um, you don't need to spend a lot of time on that.
Totally. Will support one. Also curious how you plan to balance open versus commercial models by Moonchain.
Yeah, VLLM. We had one blocker to VLLM support, which was the support for prefix LM, which we use um, for our attention. I think just yesterday I heard that like a PR had been merged to add support for that. So if anyone's interested in going and adding Moondream support to VLLM, like it's open. It should be a relatively straightforward task.
Mhm.
We have our own VLLM like inference engine called Kestrel that we are planning to release sometime in the near future. There's a few more things we want to add to it before we do that. So the solution we support for fast inference is going to be Kestrel, but VLLM support is also unblocked right now for anyone who wants to go at it. In terms of open versus commercial, still early in our thinking over here. Our plan is to still open source most of this. We've switched our license
Mhm.
to BSL. Basically, what we're saying is like, hey, you can use Moondream for any purpose, but if you're planning to offer it as a hosted API, um, that's not allowed unless you get an agreement in place with us because we want some rev share. We don't want AWS to go and host Moondream and not pay us any money.
Makes sense. What's the best 8B VLM for real world task FP16 8B or 430B? Should I fine tune or just system instruct? I didn't start the assignment and just started asking questions.
I mean, 8B VLM, what do you expect me? It's
Yes,
Moondream.
yeah.
This the second question is interesting. FP16, 8B, or Q430B. The answer is simple. If the model provider is shipping a Q430B that they've done quantization aware training on, that is going to be better. If you're quantizing the model yourself, you're often better off just running it in full precision. Like the you should post training quantization introduces a ton of loss, and often people do this like weird thing with benchmarks where they don't post the benchmark numbers for the quantized version of the model, only the full precision. So that's the thing to be careful about. In terms of fine tuning versus system instruct, it depends upon the size of the model. If you're doing a 30B, you might be able to get away with uh, prompt engineering. For smaller models, you're often going to have to fine tune because they just don't have the smarts. But it also depends on the complexity of the task. Like sometimes it's a simple prompt.
Totally. What's your view on this agent hype and agents that actually work? Computer we use MCPs and all that. And how's your experience has been?
It's pretty flaky. I think there's a lot of promise. There's a lot of promise, but for the types of tasks that we've tried to do end-to-end agents for, uh, not had that much success. Though that's starting to change. I think the latest GPT and Claude models that just came out much stronger on agentic tasks. Again, it depends upon the complexity of the task. I don't think small models are anywhere near the level of accuracy that you need to reliably do agentic work right now. Hopefully that changes soon.
Makes sense. Um, what's your view on robotics video understanding? Sorry, I messed it up. Video understanding, of course.
Um, it's a very interesting problem. We actually spent a month or two adapting Moondream to be like a VLA model. The problem is it's not something you do as a side project. It's a real serious endeavor unless you're doing it as a hobbyist where I have like my robot arm and I'm gonna try. If you're trying to do real serious robotics, you have to be a robotics company and they have the money to train their own models. So it didn't make a lot of sense for Moondream to invest heavily in robotics.
Makes sense. Um,
It's kind of there's this problem that some businesses run into where they build very valuable technology, but their best customers for that technology are companies that would never purchase the technology. It's so strategic to them that they would want to build it in house.
yeah, there's a famous take like drug dealers won't take drug.
Yeah.
Okay. Okay, this is some trivia. I guess this might sound interesting to people. Hype versus reality of post AGI talk. And what's your definition of AGI, first of all, even if you believe it? Yeah.
Uh, I think there's a big shift that is happening.
Mhm.
Whether you call it AGI or not, I call it AGI. It's pretty clear that the nature of work is going to change massively in the next couple of years. I don't think anyone who's predicting what the future is going to look like is probably mistaken. I don't think anyone can figure out what the world looks like 5 years from now.
Yeah.
But it's going to be very different. It's not going to be the way it is today. That much is pretty clear to me.
How has been your experience with? Because I see a hell lot of tweets from you on using Codex sometimes and Cloud Code. What do you think of that? I'm not specifying to one of them, but about this ecosystem of building stuff now, how it is now, and what you expect, and how you vision it. Let's say 6 months down the line.
Uh, One of the reasons Moondream is competitive is because of the existence of these coding models. Like the software uh, 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 training models is largely an engineering problem as opposed to a research problem. You need very stable infrastructure. And it's fairly complicated pieces of infrastructure. If I had to build all the software that we built in the last year before AI models existed, I would have needed a team of like 20 to 30 people. Um, 20 to 30 more people than we have right now. That's that's one aspect of what's interesting. Another aspect is like who is able to reliably use these
Yeah.
models, because you don't see this productivity boost across the board. And in my experience, it's people who have been in like relatively senior engineering positions, either as like a tech lead or as a technical manager, that are able to take advantage of these because they know how to prompt. A fundamental mistake a lot of people in make in talking to these models is they're not precise about requirements. It's that imprecise thinking that causes problems. And they're also not very good at identifying signs that something is off
Yeah.
track and being able to course correct. Um, and so it's kind of ironic that like these tools are most useful for people who are already experienced um, in working with like in treating software
Do
engineers
you
as
see the
agents.
change in shift or the transition quick with the new generation, or because? I see people who are 19, 20, or like in the young stages actually adopting to the technology and building stuff out there. So, what do you think of it, the transitioning phase?
I think they're able to get stuff built a lot quicker.
Hmm.
And as the models get better, they're well positioned to be able to continue to maintain them. Um, at the same time, I've also noticed that sometimes, like in a lot of cases, their output is constrained by how good the model is.
Hmm.
And so we've had trouble with some people where it's like, look, I feel like I talk to you, then you talk to Claude. How about I skip that and I just talk to
Yeah,
Claude
yeah,
myself?
yeah. I mean, yeah,
I think it's great for entrepreneurs if they're trying to build stuff. If you're trying to work in a company, it makes it a little challenging. I think you still need to have like fundamental skills that you build.
is something fundamentally broken about the way we are framing progress, be it anything, test and compute, scaling, uh, architecture, new paradigm, anything.
I mean, everyone posts misleading charts. I'm sure everyone's seen those meter charts, for example, on like
Hmm.
amount of time an agent can be autonomous that's gone up to 1 hour or so. What people don't really talk about a lot is the failure rate of these
Yeah,
systems. When you're putting something in production, you often care more about like take latency for example, right? Like you often care more about your P95
yeah.
latency, your P, and the way we're measuring progress right now is P50, but P50 doesn't matter, right? Like if your model is amazing at writing code but it writes broken code half the time, that's not useful to me. Or likewise with vision, right? Like if it's really accurate half the time, and so people, I think we need to start spending more time focusing on like the reliability of these AI engineered systems as opposed to just capabilities.
Totally makes sense. What hidden secret about you, which T part or the tech part of the Twitter? Mhm.
I guess before Stable Diffusion came out, I was like kind of burnt out of tech and I was trying to like become a musician.
Oh, do you still do
Yeah,
music? For-
I had this like YouTube channel where I was uploading like fingerstyle guitar covers of popular songs. I've hidden it fairly well now, so I don't think anyone can find it.
Do you
But
still
yeah,
practice?
actually one of the side projects. Oh yeah, it's a lot of fun for me. One of my side projects, actually one of the first AI projects I built was like an automated like guitar chord
Interesting.
generation website. Just paste in a YouTube video, you'll get the chords back for it.
What's one underrated habit or mindset that's been your edge in research or building product or engineering with the given experience so far?
Um, I guess for Moondream, it's been the fact that we are laser focused on delivering the best model possible.
Mhm.
We don't care about publishability, novelty. We've not written a paper yet. I still hope that we will eventually write one, but it's been that laser focus. We also spend a lot of time just closely, very, very closely monitoring training statistics. It's never fire and forget. I think we do a lot more monitoring than a lot of other people. And finally, like engineering, I guess, like we're really strong engineers more so than researchers. And so we have infrastructure that is really, really solid.
How you see AI tech Twitter, and what are the some interesting profiles you actually look up to? Yeah.
Uh, I mean, I love AI Tech Twitter. It's given a lot to us. You're able to talk to like the top researchers in the world, or like you post something stupid and they'll reply to you and be like, have you tried
Yeah.
this? So it's, I love it. I love engaging with this. There's also this part of AI Tech Twitter that's very hypey and like uh
I guess everyone is
not
part of.
substance
Yeah.
driven, that I find very frustrating, but I just block those accounts, so I don't really see them
Uh-huh.
anymore.
Okay, let's go to next. So some of the opinions, like I was actually thinking about some of the things people actually talk about. First is the displacement reality, and what's your take on it with AI?
Um, yeah, I guess like there's, to back up for a second, right? Like I read this post recently that really struck a chord with me that said like we're living in the most important
Yeah.
century when it comes to like what the future of humanity, the human experience looks like. I'd also argue we're probably living in the most important 10 years of that phase right now.
Hmm.
So I think a lot of us have responsibility in like driving this phase shift to a positive outcome for humanity, and that's everyone's job right now. There's a good future and a bad future. A bad future looks like hyper surveillance, power concentration, government overreach, etc. There's a good version of this future that we can drive towards where there's a lot less concentration of power, and that's one of the things AI enables. Like every single person now can achieve far more with the help of AI than they were able to achieve previously. So places where previously you had these reinforcing loops where the bigger a company gets, the harder it is to compete with them, that shifts. So like a good version of the future might be like a lot more small companies dealing with each other as opposed to like these hyperscalers, big
Mhm.
companies. And intelligence is kind of just a utility, like I don't know, water or your internet connection that you can consume from a couple of different providers that you use to build your businesses. So I hope that's where we end up. In terms of job displacement, again, it's kind of related to what I said.
Yeah.
Like as we build out this new technology, like it'll create some more jobs. I heard electrician salaries have gone up to 300,000. Uh, they're having to like get H1B electricians and stuff to build data centers. So there's new types of jobs being created, and I think a lot of more people will have entrepreneurship as an option open to them where it previously wasn't possible because you don't need to raise money because now your marketer can be an AI agent, your sales guy can be an AI
Yeah.
agent. You don't have to hire people, so it reduces the cost of starting a business.
That leads to a question now, like what's your vision of next decade? Because people are optimizing on robotics, biotech, building out the incredible stuff with AI. So do you think everything
Mhm.
these stuff will converge at some point of time, and there will be different world we'll be living in where everything will be uh, optimized in a way that that doesn't require, I mean, like how UI is now replaced with the intent and action and all. So what's your view on the let's say for next decade or the end of the decade? Yeah.
I mean, I think it's going to look very different, but the thing is, like, people are really, really quick to adapt to change. Like, when I go to SF, like, if we already have self-driving
Yeah.
cars, how insane is that? And it gets normalized after some point. It's just like, yeah, sure, it's a Waymo, I'm sitting in it, there's no driver, it is what it is. I suspect we'll see a lot of change, but we also adapt very quickly to change, so it is what it is.
Yeah, but the pivot is important ultimately. Makes sense.
Mhm.
um, Also, the thing you have changed your mind on. So what did you believe about AI 2 years ago that you have completely reversed on?
Coding, AI coding. Like 2 years ago, I was an AI coding skeptic. Actually, when we started talking about AI, one of the first questions Jay asked me, Jay, my co-founder,
Mhm.
was, "So when do you think these can like start writing good code?" And I was like, there's a hallucination problem. So like maybe we give them building blocks and they can orchestrate it, but I won't trust it to write a login page by itself. It needs to have pre-built components it can assemble. I was dead wrong about that. I think I realized about
Mhm.
last December or so. They're amazing at coding. I'm a big fan.
And I guess it will just go beyond. Totally.
Hmm.
I guess we are nearing to the end of the podcast. I guess I have some couple of questions left. So, what do you think everyone gets wrong? What's a common belief in AI that you think is just flat out wrong?
I mean, I might have to let me think about this. Do you have another question we can talk about while I noodle on this?
So yeah, this is something I want to have people get a value out of this podcast. So let's say imagine kids going to high school or college and doing stuff, conventional stuff out there. The professors, the current age professors, all not too well updated with the current stack of the technology because it's new for everyone. So what do you think people should look after to? Because there are a lot of resources out there, but to be to be the top, let's say to be on the top of the 1% of the technology, what one should optimize for, or what I'm not just asking about the roadmap, but what you think that could shape them better. Yeah.
Yeah, I guess you already jumped to the really critical part of this. Like, if I were 20 years old right now, I'm in a world where like the future is far less certain. Like, are there going to be coding jobs in 5 years? How many of them are there going to be? What skills should I optimize if I want to build software in the future? These are all very much up in the air. The ways in which to train people to be good at those jobs have not been discovered yet, or even what the nature of those jobs are going to be. So you should optimize for being good at learning, being good at adapting, and most importantly, being in the top 1 to 5% of whatever field you're in. As long as you're in the top like 5%, you'll be fine. If you're not, then like find a way to get there or find a different field in which you can be in the top 5%.
Interesting, totally. I guess we are pretty much. Do you have any answer for the previous question?
I guess a lot of the ways in which people
Hmm.
think about AI is wrong or is unproductive. I see a lot of people make philosophical arguments of like this should work because I have this theory that human brain works like this, or because like self supervision has to work. And a lot of these are emotionally grounded as opposed to practical. And or maybe I'm just too stupid to understand their arguments, I don't know. But for me, that stuff just never lands. I'm like, look, I just want to see what works and then go do that. Like, what are you talking about?
I guess, yeah, this is wrap. Vic, thanks for joining Ground Zero. This was fun. If you're not following his work, go check out Moondream. I'll put up the links. I guess like the major audience I'm catering is from Twitter, so everyone knows about the podcast and what is being up to. And if you got something out of this, yeah, share your opinions and I guess you have enjoyed this podcast.
Yeah, hey, thanks for having me. This was a lot of fun. Really appreciate it.
Next, yeah, we have started ground zero to the to make it a better frontier. How much we can do, and yeah, partner with us. There's a page. Go ahead with that. DM me questions and what more we can do to provide as much value as we can. Thank you for joining us. Stay tuned for the next one. See ya.